Good evening. Today we're going to discuss how do we read a heating or cooling curve. Well, a heating or cooling curve is really just a graph that tells us some information. Let's look first at a heating curve. On a heating curve, you'll see temperature on the y-axis. On the x-axis, you'll see that it says time as heat energy increases. So over time, the substance is going to be absorbing heat from its environment. As a substance starts out, it is in the solid phase with the lowest temperature and the lowest amount of molecular kinetic energy. As that solid absorbs heat over time, it's going to eventually reach the point where the molecules start to melt. As the molecules are melting, the temperature, you'll notice, remains the same. So the temperature is increasing until it hits the melting point. At the melting point, the temperature remains constant. Once all those solid molecules have converted into liquid, the substance will be in its liquid phase and able to increase its temperature once again. The temperature will increase until that substance reaches its boiling point. Once it reaches its boiling point, it will go through another phase change. And during a phase change, the temperature will remain constant until all the molecules are converted into gas. Once in the gas phase, the substance temperature can start to increase again. The reason I know that the melting point is down here and the boiling point is here, and I know they are melting and boiling, is because I know that substance is absorbing heat energy because the temperature is increasing. Some things to keep in mind when we're looking at a heating or cooling curve is that the slanted lines indicate an increase or decrease in temperature. A line that slants down over time is cooling. And a line that slants up over time is heating. Or we can think of it as absorbing heat from the environment or losing heat from the environment. So lines that are slanted up indicate that the substance is absorbing energy, and lines that slant down indicate that a substance is losing heat energy. Flat lines indicate that the substance's temperature is remaining constant, so that tells us that the substance is going through a phase change at that temperature. So, in this diagram down here, if we wanted to know what temperature this substance melts at, we would just go find the flat line and go directly across and look at the temperature on the y-axis. We could do the same if we wanted to know its boiling point. We would go where the flat line is, go straight across, and that would tell us the temperature at which the substance boils, a physical property of that substance. Let's look at a cooling curve. Here, you'll see our setup. Here in our cooling curve, the substance will start out in the gaseous state and lose heat energy and cool. So once this substance loses enough heat energy or cools enough, it will hit the point of condensation when that gas turns to a liquid. And you'll see the temperature remains constant. So the flat line tells us the temperature is constant, so we know it's going through a phase change. As it continues to cool, it'll eventually become a liquid. And as that substance continues to lose heat, it will eventually hit its freezing point. The freezing point is the temperature. The phase change is called freezing. As the substance is freezing, the temperature remains constant. And you notice the flat line. Once the substance is completely solid, it'll continue to cool again. So the molecules will get slower and slower and slower. So they vibrate at a slower rate. So quick things to remember. In a heating curve, the lower flat line indicates melting occurs. If you look at the temperature at which that happens, it's called the melting point. The upper flat line is where vaporization or boiling occurs. And if you look to the left at the temperature at which it occurs, it's known as the boiling point. And in a cooling curve, the upper flat line indicates condensation is occurring, and that's the condensation point. And the lower flat line indicates freezing is occurring, and that's the freezing point. And the freezing point is indicated by a temperature. Okay? That's all we have for this evening. If you have any questions, please feel free to ask. We'll see you tomorrow.